Hey guys, welcome back to Chemicals TV. Good to have you back. We are still on our video on what exam possible question when it comes to what chemistry. So now from now to your exam, I'm going to show you some exam possible questions you likely see in your exam. So you want to pay close attention to me here. Now I have for question one to what question 7 because this is what the board can actually carry. Now you are really need to pay class sharply because if there's anything you don't understand before, this class will make it clearer for you. You get so we are teaching what different aspect of what of chemistry and to see how questions are being set when it comes to what Jamb chemistry. So you have to pay close attention here. Now the good thing is that some of the questions we are going to answer in this class here, we are going to see them in your exam, either your Jamb exam or your post you are going to write. You get because these are key questions Jamb have repeated over and over and over what again. So let's get into it here. That the ion which is isoelectronic with neon is so the word isoelectronic. So what do you understand by the word isoelectronics? Isoelectronics means what they have the same electronic what configuration. So when two ion or elements have the same electronic configuration, they are called isoelectronic what species. I get. So here they're asking you which of these ions are isoelectric to neon. You get so neon is what is 10, right? So you have to write the electric configuration of what of neon. So that is why if you don't know how to write electric configuration of neon, you need to check out my video where it comes to what chemical bonding and writing electrical configuration. The link will be at the description below. You have to go check out that video because that video explains step by step on how you can what write electrical configuration and how you can what identify the period, the group, and the element, the period, the group, and the what valence electron in the words of element in the periodic table. You understand? So if you don't know how to write the link configuration here, I will leave the link at the description below. But for the sake of this class here, now if you want to write the link configuration here, you need this one here: 1x, 2x, 2p, 3x, 3p, 4x. This is what you need now. Right there. So majority of what you are going to see here is going to be 1x, 2x, 2p, 3s, 3p, 4x. Now remember, s can accommodate an electron, s can accommodate what 2 electron, s can accommodate 2 electron, p can accommodate what p can accommodate what 6 what electrons. So you have to what take note from 1x what to 4 what x. Do you understand? So now let's write a link configuration for each of these what ion here. But first of all, let's write a link configuration for what neon. Neon, which is what Ne, the electron number is what is 10. You understand? So if you want to write the link configuration, you got to be what 1x. This is a 1 what x. So it will be 1x. How many electrons is it going to take? You're going to take what 2 electrons. So it's going to be what 2. It's okay. The next one is what is 2x. 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 S will accommodate how many electrons? 2 electrons. How many have we used? We have used what 6. We have used 4 electrons. Left what is 6. The next one is what 2p. 2 what p going to be 6. So the electric configuration of neon here is what the electric configuration of neon here is what 1x to 2x and what 2p6. Another thing you want to understand here is that now what about isoelectronic species? That they have the same numbers of electrons. So now in order for you to do this thing here, for you not to waste your time, ask yourself how many electrons do I have here? How many electrons do I have here? How many electrons do I have here? And how many electrons do I have here? Once you see the one that have equal electron with neon, that is what isoelectronic what species. Just so if you look at aluminium is what 3 plus, right? Then it have what lost 3 electrons. So now whenever I see 3 plus, right there, that is whenever I see plus, that element have what lost 2 electrons, right there. So now subtract the numbers of the electron from the proton. Now aluminium normally the proton number is what is 13, right? Or the atomic number is 13, right? Now because if I've lost 2 electrons, how many electrons does it have left? It's going to be 10 because 13 minus 3 is what is 10. So here we have 10. Aluminium is 10. Al3 plus is what the electron is 10. So this guy have the same electron number with what neon. It means that you're going to have the same electric configuration for what neon. Just now let's move on. Chlorine. chlorine minus, it means that it have what? Gain one electron. It have what? Gain one electron. So whenever I see negative sign, it means that it have what? Gain an electron. So because here we have minus here, just minus, that is it have gained one electron. Normally chlorine is what? Is 17, right? Right there. So when it gain one electron, that become what? That become what? 18. So here we have what? 18. Do you understand? Potassium. Potassium is 19 normally, but here it have what? It have what? Lost one electron. Now because it have lost one electron, 19 minus 1 is what? Is 18. So you have what? K plus is what? Is 18. Do you see that? Then phosphorus. Now 3 minus. That 3 minus that would gain 3 electron. Normally phosphorus, the electron is what? Is 15, right? Now because it have gained 3 electron, 15 plus 3 got to be what? 18. So phosphorus, when I see P3 minus is 18. So you see that chlorine ion, potassium ion, and what? Potassium ion and what? Phosphorus ion, they all have the same electron what? Number, 18, 80, 80. So these ones are what? Isoelectric species toward each other here. Right there. Now aluminium is an isoelectric species toward to neon. Why? Because now the aluminium 3 plus have the same electron number toward that of what? Neon. Do you understand? So these ones are totally have because they are all 18, so they're arts. So the what? The ion that is isolating toward to neon is what? Is aluminium, because you got to have the same electric configuration for towards to neon. Do you understand? So the answer is what? Is A. Very important. That is what? That is the answer. Do you understand? Now let's move to what? Question 2. Question what? 2. If you understand the question 1, please leave a comment section that you understand the question 1, so that I will know what I'm doing here. In case sometimes you don't understand. So if you don't understand, leave a comment section that you don't understand the question 1. But if you understand the question 1, also leave a comment section that you understand the question 1. It's very important to do this here. So now let's move to what? Question 2. Let's move to what? Question 2. Element X has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4x2. If atomic number and group number in the periodic table respectively are would be. So I don't know why this place here the question number 1, so I will be able to answer this question 2 with it. Okay, now here we have the electron configuration. Here we have 1x2, 2x2, 2p6, 3x2, 3s2, 3p6, 4x2. First of all, let's get the atomic number. The atomic number, please pay close attention. The atomic number is what? When you sum everything together, just the atomic number. So we have 2 plus 2 plus 6, 10 plus 2, 8 plus 2, 12 plus 2 plus 6, 18 plus 2, what? 20. So the atomic number is what? Is 20. Is what? Is 20. The atomic number is what? Is 20. Now when you look at it very well, here we have 20, here we have 20, here we have 15, here we have 12. So these two are already arts. Do you understand? These two are arts already. So it can either be this guy or this one here, right? So now let's get what? The group. Right there. Let's get what? The group number. Now, for you to get the group number of an element for what? Electron configuration here, you have to what? Look at what the highest energy level. Now, if you look at this thing here we have 1, here we have 2, here we have 3, here we have 4. 4 is the highest energy what? Level. 4 is what? Highest energy level. So if you look at 4 here, we have what? 4x2. Right there, 4x2. Now, how many electrons do you have here? 2 electrons. How many electrons do you have here in the word 4s? 2 electrons. Now, because here we have 2 electrons, that is my group number is going to be 2. Do you understand? Now, because here we have x, 4x, the highest energy level is what? Highest energy level is what? Is 4. So we now have 4x2. Do you understand? Now, because here we have 4x2, you take what? The mass of this electron here. How many electrons do you have here? Here we have 2. That is, this guy belongs to our group 2. So the group number is what? Group 2. So this one is not the answer here, but this is what is the answer. Group what? 2. Do you understand? Now let me explain. Now let me explain something else for you here. Do you understand? Now let's assume that we remove this 4x, right? We remove all this 4x and make it to be what? To be 3. To be what? 3. It's okay. Now if they should ask you here, please pay close attention here. If they should ask you, if you are being asked what is what atomic number? What is atomic number? Atomic number is when you sum all the what electron. Idea. So it will be 2 plus 2 plus 6, which is what is 10, plus 2 plus 3 is what 15. So the atomic number is what is 15. Do you see that the atomic number is what is 15? So how do you get the group number? Group what number? Now, therefore, look at what the highest energy level, right? Now, here we have first energy level, second energy level, third energy level. The highest energy level here we have 3. You understand? 3. Now remember that one we have 4, and we only have 4x2. But here we have 3. Here we have 3x2, 3p3, right? So you have 3x2, 3p what? 3. Right? 3s2, 3p what? 3, right? Now, because they are both 3, 3, there is an energy level here. Now, in this situation here, you don't just take only this one here. Now, because here we have 3x, 3p. Now, you sum the electron together. So that's going to be 2 plus 3, which is going to be what? 5. So going to be what? 5. Do you understand? So, assuming we have something like this, the atomic number is going to be what? 15 when added together. While the group number will be what? The group number will be what? 5. You get? Now, let me give you one for you to try. You leave it at the comment section. Let me give you one for you to try. Imagine you have something like this. Here we have 1x2, 2x2, 2p, 5. Now, what is the atomic number? What is the atomic number? What is the atomic number? And what is what group what? Group number. Leave it at the comment section. You get? And let me give you another one. If for example here we have 1x2, 2x2, 2p6, 3x1. What is the group number? Please now take this to down here. Take this down here. Now, what is the group number? What is the atomic number? What is group number? What is the atomic number? What is the group number here? I want to see your answer at the comment section. It's very important. You get? I want to see your answer at the comment section. So we are done with what? Question number what? 2. So let me go to question number 3. So I'm going to write this up here. So then look at what this guy. An element X has 2 isotopes. Isotope S63 and isotope S65 with about than 70% and what 30% respectively. The relative atomic mass of X is dash. So what is the relative atomic mass of X? Now, whenever you come across a problem when it comes to isotope here, now let me give you a simple formula you can make use of here. So we have which one? Relative atomic mass equals to what? A1 times P1 plus what? A2 times what? P2. What? P1 plus what? P2. It's okay. Although I have done a complete video on this one here. You can check out what? You can check it out. Now, A1 means what? The relative abundance or what? No, sorry, means what? The atomic mass of what? First isotope here. So whenever I have A1 means what? Atomic mass of the first isotope. A2 means what? Atomic mass of the second what? Isotope. P1 means what? Percentage abundance of the first isotope. P2 means what? Percentage abundance of the second what? Isotope. Now here we have my first isotope. Here we have second isotope here. My A1 is going to be what? 63. It's okay. My A1 is going to be what? 63. Now you can see that isotope. The isotope is a phenomenon whereby 2 atoms of the same elements have the same atomic number but different mass number. So these are called atomic what? Mass. So A1 means atomic mass of the first isotope. A2 means what? Atomic mass of the second what? Isotope. Now, for each isotope here must have their what? Percentage abundance. You get? So my A1 is what? 63. My A2 is what? 60 what? 5. Can you see that? Now when I do my P1, my P1 is going to be percentage of what of the first isotope, percentage abundance of what of the second isotope here. And here we have 70 and what 30. Mean that first and second, so going to be 70% and what 30 what percent. Now when you sum all together, it's going to be what 100, right? So the next one I want to do now is what impute what my formula there. So going to be R A equals to what? A1 is what 63 times what 70 plus what? A2 is what 65 times what? 65 times what? 30, right? Over what? 70 plus what? 30. Can you see that? So take it down. Consider as it is, right? So the next thing you want to do here, well, let me write this place out because you don't need it again. So the next thing you want to do is to what? Bring out your calculator. So use your calculator to what? To get your answer. You have 63 times 70 plus 65 times what? 30 divided by 100. So now it's going to be what? So my RAM, now when you do everything, you're going to be what? 63.6 AMU. So let's look at what the option. You have 63.30, 63.60, right? So which is this is what the answer. This is what the answer. C is what is the answer, right? So that is it. So we are done with the first three questions here. So let's look at what question 4. So let's look at what question 4. How many unpaired electrons are there in electric configuration of an element with atomic number what? 8. So therefore, you want to write the electric configuration of what? Of 8. So let us say the element is what 8, having the atomic number of 8. So remember I told you you have to use one when I take the configuration, I use what 1s, 2s, 2p, 3s, 3p, 4x, right? And you're filling what the electron from lowest to what to the highest, right? So here we have 8 electrons. So let's take the first one. Here we have 1x2. 1 what? X2. Now, if you should remove 2 electrons from 8, you will have 6 electrons. Let's move to the next one. 2x. Here we have what? 2x2. Can you see that? How many electrons do we have left? We have what? We have how many electrons do we have left? We have 4 electrons left. So let's continue. Here we have 2p. So 2p because p we accumulate 6 electrons, right? But we have only 4 electrons left. So here we go to what? 4. So now, in the sense that before you can predict what the numbers of unpaired electrons in an atom, therefore you have to write the electric configuration. You understand? Now, another thing you want to put in your mind is that now x orbital only have 1 suborbital. P orbital have 3 suborbital. Please kindly go and check my video on quantum number. What about the principal quantum number, the azimuthal quantum number, the magnetic quantum number, and the spin quantum number. Get. Because you see questions in the exam there, right? So now what happened here? Here we have P, right? So if you look at P have how many suborbital here? 3 suborbital. Right there. How many electrons do you have? Here we have 4 electrons. Now, how do you fill the 4 electrons here? In this what? 3 suborbital. Remember, in Ohm's rule, when filling electrons into degenerate orbitals, electron must spin up before spinning down, right? So the electron must spin up before spinning down. That is called Ohm's rule. Ohm's will state that when filling electrons into degenerate orbitals, the electron must spin up before spinning down, right? So how many electrons do you have here? Here we have 4 electrons. So it's going to be 1, 2, 3. Can you see that? How many electrons do you have left? 1. So it's going to be what? 4. Right there. So from here now, you can know what numbers of paired and what unpaired electrons. Now, this one is what is paired. This two are what are unpaired. So how many paired electrons do we have here? Here we have 1 paired electron and 2 what unpaired electrons. So let's look at what they say should ask. How many unpaired electrons are there in an electric configuration of an element with atomic number what 8? Now, is it 2? Is it 3? Is it 4? Is it 5? Now, after this one here, that is when you know the numbers of what unpaired electrons. Here we have these 2 are unpaired because no electron again because you only have 4. So how many unpaired electrons do we have? Here we have 2 unpaired electrons. That is what? That is the answer. Yeah, that is what? That is the answer. as easy as that. That is what answer, right? So if you understand question 3, leave a comment section that you understand this question 3, so that I will know. If you don't still understand, also leave a comment section that you don't still understand, so that I will know what to do. So let me to question 5, because we don't have time again. I'm having a class. So question 5, let's go question 5. So which group of the periodic table does an element with atomic number 16 belongs to? Now this is what is a fine question. This is a very good question. Now let's assume that the element is what is y. Y is 16. They said the element is 16, right? Now they're now asking you what is the what period, to which period, to which group of the periodic table, that which group does this guy belongs to? Right there. Which group does it guy belongs to? So the next what I want to do is what, to write electronic what configuration. So let's write the electronic configuration. Remember, we are using this one here: 1s2, 2s2, 2p6, 3s2, 3p4. So it's going to be 1x2, 2x2, 2p6, 3x2, 3p4. Okay, now let's look at it very well, right? 2 plus 2 plus 6 is what? Is 10. Plus 2, 12. Plus 4 is what? Is 16. 16 here, right? So how do we know the numbers of what? How do we know the group number? I get the group number. So now what I want to do here is what? What is the highest energy level? My highest energy level is what? Is 3, because here we have first energy level, which is 1, second energy level, which is what? 2, third energy level, which is what? 3, right? So the 3 here, I have what? 3x and what? 3p. So bring it out. 3x, 3 what? P. Now how many electrons do we have here? We have 2 electrons. Here we have what? 4 electrons. Now because 3 have x and p, right? So now to get the group here, you sum their electron number here. So how many electrons do you have in x? 2. How many electrons do you have in p? 4. Right there. 2 plus 4 is what? Is 6. 6. So we're going to be this one here. So because it's only written in what? In Roman figure. Right there. 6. So that means if you go and check this group here, this element with atomic number of 16 is phosphorus. No, it's sulfur. Element with atomic number of 16 is what? Is sulfur. And it belongs to what? Group 6. So the answer is what? Is group what? 6A is what is the answer. Do you understand? So let's move to what? To the sixth one, right? What type of bond exists between an element X with atomic number 12 and Y with atomic number of 17? So this one will be a little bit tough. I get it. So now there are two main type of bond. There are what? There are two main type of bond. They are called ionic bonding. Ionic what? Bonding. Ionic bonding are what? Covalent bonding. Covalent what? Bonding. And this covalent bonding is what divided to. This covalent bonding is not what? Ordinary covalent. And you have dative covalent, which also called coordinate what? Bonding. Right there. Now, what is ionic bonding? Ionic bonding occur between metal what? Non-metal. It involves the giving out of what? Of electron. So we're talking about for two elements to have covalent bonding. That is, one is willing to what? Give out electron, and one is what? Is willing to what? To accept electron. Right there. And the main reason why one is willing to give out electron, because you want to attain the octet electron. So the reason why atoms bond together is because they want to attain the what? Stable configuration we call the octets. And the only way to do that here when it comes to ionic bonding is by one atom giving out what? Of the electron, that is giving out the atom's electron. So when you lose the atom's electron, you now have the octet electron. On the other hand, another element have to what? Be available to what? To accept that electron. Now when that atom accepts that electron to the atom's shell, you now become what? The octets. You get. So that I call covalent bonding. Now that is called ionic bonding. Do you understand? In covalent bonding, this ionic bond here is between metal and non-metal. Metal give out what? Metal give out electron. Non-metal will accept what? The electron. A good example is when you have NaCl. Right there. Sodium chloride, magnesium magnesium nitrates. I get magnesium nitrate or nitride. Here we have aluminium chloride. I get so any compound you see between any compound you see between that have metal or non metal, they are what ionic what that they are called ionic what compound because it involve what the losing and what gaining of what of the electron. Do you get that? Now, when it comes to what covalent compound here, covalent compound means it occur between non-metals. So when non-metals combine together, they are called covalent compound. It involves what sharing of the electron. So when two elements share electron in a bond, it's called what covalent bonding. Right there. And we have two types of covalent bond here. We have called other covalent bonds. Other covalent bond is when the two elements themselves share bonds. Right, they share what the electron. A good example is when you have CO2, when you have what H2, F2. We have any of them. Right there. Now, dating covalent bonding, it also involves the sharing of the electron. But guess what? One element or one atom or one molecule brings what the donating of the electron. Just one atom brings what the one that is being donated. A good example is between what a NH3 and what H plus. I am so to form what to form NH4 plus. Now when I say NH4 plus, it's called dative covalent bonds. Do you understand? So I'm not going to this process now because I'm just trying to explain to you so that you can understand better. Now, so when you now say a question like this, you now have to say, now the element with the atomic number of 12, is it a metal or a non-metal? Why the element with the atomic number of 7, is it a metal or non-metal? So how do you do that here? So let's try and figure this out. Let's try and figure this out. So X, if you look at X is the atomic number is what is 12, right? Y, the atomic number is what is 17. I get. So let's use old electronic what configuration because with old electronic configuration you can easily what know the one that can easily give and the one that can easily what get. In the old electronic configuration, which is what 2882. That is the first energy level will take 2 electrons, the second energy level will take 8 electrons, the third take 8, the what fourth take 2. Do you understand? So if you should do that here we have 12, you're going to do what 282. Now let me ask you here, if an element have this thing here 282, now how will this element become the octets? Now because here we have 282, because here we have 2, here we have 8. For this one to behave like this guy here, now there is no way it can accept 6 electrons. It's not possible. It can't accept what 6 electrons. So it has to give out what the atomos electron. Now when you give out the atomos electron, then what you're going to get? You're going to get what 2, 2, 8. I get. The metal is now going to be what X2 plus. Do you know what I mean here? You know that this guy have lost what 2 electrons in the atomos shell. That what lost 2 electrons from the what atomos what shell is very important. That what lost 2 electrons from the what atomos shell. You get that? So that is what S2 plus. Now look at this guy here. Here we have 17. Here we have 287. Right? 2 plus 8 is 10 plus 7, which is what 17. So now for this guy to have the octet, he needs 1 electron. Now once he accepts 1 electron, that becomes what 288. So going to be what Y minus I get. So this guy is what is a this guy is what is a non-metal because non-metal accept electron, metal donate what electron. I get. So when two elements are combined together and one is metal, one is non-metal. Now the bond that is being formed there is called ionic what bond. It's called ionic bond or electrovalent bond. Do you understand? So ionic bond is also the same thing as electrovalent bond. I did say that before. Ionic bond is also the same thing as electrovalent bond. So electrovalent bond occur between metal and what non-metal. Yet metal give out what electron, non-metal will accept what the electron. So this guy with donation will accept electron. You get. So the answer is what valent what bonds. Do you understand? So let's look at what the last question in this class here. A metal X form two bromine with the formula XbRO2 and what SbRO3. What type of bond is it between X and B? They already say a metal. Now, once you hear the word metal, is what is ionic bonding. There's no point of wasting your time here. You get that? Is what is ionic bonding. So when you see this kind of question, when you say metal form bond with bromine, so X is a metal. Bromine is what is a non-metal. So what type of bond is it between bromine and what X, which is metal, and bromine, which is non-metal? Is what ionic bonding. So in saying that, there are some questions you don't actually need to waste your time. That is why you need to go to be familiar with all these things. So that is why I'm here to guide you, to coach you, and to put you in the right track in case you are still having issues. The Jamb is very close, but this video here to go a long way to help you. So we are done with this class here. If this video is helpful, please leave it at the comment section that this video is helpful. Now, please kindly share this video here to other persons. We just hit 3K subscribers, which I'm very, very grateful for. Thanks to you guys. Thanks to you all sharing this video here, watching this video, liking and commenting. Because of you, that I'm here. You get so, but I know that we can still get to 4K subscribers in the next few weeks if you put much effort. You get so, please, if this video is helpful, please leave it at the comment section that this video is helpful. You get, and if you have not liked this video, please kindly like this video. Please kindly share this video too. Now, there are some other videos that are also coming up. You get so that's why you want to actually